We are in section 2.2, patterns and linear functions. Now the whole gist of this section is showing how a pattern is basically a relationship. And relationships can be represented using words, tables, equations, ordered pairs, and graphs. So everything encompasses each other, and everything actually can be involved to write a function, to write a graph, to write a table. This does take some time, and there is quite a bit of writing, but we're going to go one step at a time, and let's start. So let's start with a problem that involves rectangles. All right, so we're going to start with a diagram. In the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. So you're going to do four things: a table, words, an equation, and a graph. So it says, what do we want to write a relationship of? Between the number of rectangles and the perimeter. So let's start with a table. A table we can just do a little t-table. So here's our table. X is going to be the number of rectangles. So X represents the number of rectangles. So we know that we have one rectangle, two rectangles, three rectangles, and four. And then what we want to find is Y, which is our perimeter. So I'm going to squeeze this in here. Number of rectangles, and Y represents P, which is our perimeter. So let's look at the first example. What is the perimeter of this first rectangle? Well, we would have 6 plus 1 plus 6 plus 1. But I'm going to use the formula for perimeter. Formula for perimeter is 2 times the length and 2 times the height. So we're going to write 2 plus 12, and that equals 14. Now the last column is our ordered pair. Our ordered pair is x comma y. So we're going to write the ordered pair 1, 14. Now the second rectangle. The second rectangle, what do we have? We have 1, 1, 1, and 1. So this is 1 plus 1 plus 1 plus 1. So that gives us 4 plus, what are the other two sides? 6 plus 6, which is 12. And remember, this is a big rectangle, so we do 6 plus 1 plus 1 plus 6 plus 1 plus 1. So the 6 plus 6 is 12. And that gives us 16. So we would write that as the ordered pair 2, comma, 16. 3. Well, we have 6 plus 6 still, but here now we have 3 plus 3. So the top is 3, the bottom is 3. That gives us 6 plus 12, which gives us 18. So our ordered pair would be the third rectangle, gives us a perimeter of 18. And lastly, we have 4 plus 4, so that would be 8 plus 12 equals 20. And that gives us the ordered pair 4, comma 20. So right now we've written them as an ordered pair with a table. So we've made a table. We used x. Now remember, we have an independent and a dependent variable. The independent variable is the number of rectangles. That's your x. Because y changes depending on what x is. So y is the dependent variable. Y depends on the number of sides. The perimeter depends on how many sides or how many rectangles we have. So x was the number of rectangles, y is the perimeter of the figure. Now remember, x is your input. Now we're going to talking about this later, but x is your input. X is always going to be your input. X will always be your input, what you plug into something. Your y is your output, and we write that as an ordered pair xy. Now here is the absolute most important thing about this table, is look for the pattern. I want you to come up with a pattern yourself. And the best way is to look at the relationship between x and y. What's happening here? What happens as x increases by 1? As x increases by 1, y increases by what? Y increases by 2. So, here's what we're going to look at. We're going to look at this perimeter here. This is your equation. You don't actually realize this, but this is your equation. I'm going to rewrite this. So I'm going to use white. I'm going to take this box right here, which is the y box, and I'm going to bring it over here, and I'm going to separate it. Whoops, let me erase that. So if you look at this, look what our perimeter did. Every single time, the 6 stayed the same. But you added another 1 on the top and bottom. The sides stayed the same. You never added another 6 because you had a 6 on the left and a 6 on the right on each of these shapes. But you added 2 every time. And that's why you have this plus 2. So if you notice, you had 2, but you took 2 times 1, and that gives us this 2. 2 times 2, that gave us this 4. 2 times 3, that gave us the 6. 2 times 4, that gives you the 8. So our equation would be this. Y equals the 2. The 1, 2, 3, and 4 represent x. And the 12 is what stayed the same. Now you may say, I don't get how he did that. So I'll show you another way. As x increases by 1, and this is by looking at your ordered pair, your x must increase by 1. This only works if x increases by 1. If x increases by 1, what is the constant increase or decrease in y? Well, if you look at this, as the x increases by 1, the y increases by 2. So the y increases by 2, that's how you get this 2 right here. So you would actually get y equals 2x. Now here's how you get the 12. I want you to plug in any one of these numbers, like 1, 2, 3, or 4. Let's just say 1. If you plugged in 1, what's 2 times 1? 2 times 1 is 2. But we know we have to get a 14. So 2 plus what gives us that 14? It would be plus 12. And you could do the same thing with any of the other numbers. If you plugged in 2, we know we have to get 216. So if you plugged in 2, your input, 2 times 2 gives us 4. 4 plus what gives you the 16? Well, it's 12. Plug in 3. 3 times 2 is 6. 6 plus what gives us 18? It'd be 12. So this right here would be our equation. Now we still have to write this as a graph. Now, since we only have positive values, we only need the first quadrant. So we start at 0. Our x values only go from 1 to 4. So 1, 2, 3, 4. And we have to label it. So our x-axis is the number of rectangles. Our y-axis goes from 14 to 20. So I wouldn't count by 1s. You'd have to go all the way up to 20. Let's count by 4s. 4, 8, 12, 16, 20, 24. And this is your y-axis. And we're going to label it, and I ran out of room. But you need to label that side, the y-axis, which represents the perimeter. So if we graph, after one rectangle, we have 1 with a perimeter of 14. So we graph over 1, up 14. Then we have 2 rectangles as a perimeter of 16. 3 rectangles is a perimeter of 18. And 4 rectangles gives us a perimeter of 20. Here's probably the most important thing that's going to be a little different. You wouldn't connect the dots. Because if you connect the dots, you're then saying that all the numbers between 1, 2, 3, and 4 would work. Well, the number of rectangles has to be like whole rectangles, so you cannot connect them. So it jumps. 1 rectangle, 2 rectangle, 3 rectangle, 4. It doesn't get connected, because if it gets connected, you're telling me all the numbers in between also are solutions. Well, you're not going to have 1.3 rectangles, or 1.5, or 4.9, or 3.7 rectangles. So that would be your table. Now look at the got it problem on page 103. It says, in the diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship as a table, words, an equation, and a graph. So we're going to start with our table. Our table, we have x and y, and then our order pair of x, y. X, what are we doing? We're finding the relationship between the number of triangles. So x is the number of triangles, and y is the perimeter. Now the perimeter is the dependent variable, because that represents what y is going to be by what x is. So x is the independent variable. So if you look at the shaded region at the top, it explains what your dependent variable, your independent variable, inputs, outputs, what all that talks about. Make sure you study that and you understand that. So how many triangles do we have? We have 4. So we're going to put 1, 2, 3, 4. What's the perimeter of the first triangle? 3 plus 3 plus 4, that'd be 10. So our order pair will be 1, 10. The next order pair, well, let's figure out what the second shape is. So the second shape has a perimeter of what? 14. So that would give you 2, 14. 3, 18. And you should start noticing a pattern. And 4 triangles. Be 22. So we just represented that as a table. So in words, what are we going to do? Before words, what I would rather you do is actually write an equation. It's going to be y equals. Now remember, y equals. How do you find the perimeter? What do you do to the x numbers to get y? Are they just adding 9? Each of them adding 9? Are they just multiplying by 5? Are we subtracting 10? We want to know how you get that. So y equals, and here's how you do it. Look at what happens in each of these ordered pairs. If only the x increases by 1, and we'll get to problems where it doesn't, but as of right now, this does increase by 1. What happens to every y value? What's happening to your y values? They're increasing by 4. If they decrease, then it'd be a negative. So because it's increasing by 4, we put a 4x. However, that does not mean that we multiply all your x numbers here by 4. 4 times 1 is not 10. 4 times 2 is not 12. 4 times 3 is not 18. But let's think about what happens. Plug in 1. What is 4 times 1? Well, you get 4. 4 plus what gives you the 10 that we want? Okay? Let's plug in 2. What's 4 times 2? 4 times 2 gives you 8. Remember, these are the values of x. So all I'm doing is taking all of these and plugging them in. 4 times 2 is 8. 8 plus what gives you 14? 4 times 3 is 12. 12 plus what gives you 18. 4 times 4 is 16. 16 plus what gives you 22. You should notice every time you're adding 6. So there's your equation. So in words, what's happening? This is important. The words are showing that you multiply the number of triangles by 4 and add 6. So that's what words mean. You multiply by 4, the number of triangles by 4, and you add 6. So now that's our equation, and that was your words. Now we put this as a graph. Now your graph would look something like this. Now it's obviously important that you need to have graph paper because my lines don't exactly show a linear function or a constant. So if you look, I just counted by 5s on the y-axis, and on the x-axis I counted by 1s. Make sure you label what do these numbers represent, what do the x values represent. This would be number of triangles, and the y-axis would be the perimeter. Now we want to do B on the top of page 104. It says, suppose you know the number, which is n, the perimeter of n triangles. What would you do to find the perimeter of n plus 1? Well, you'd add 4. Because what does that mean? How do you go from one triangle to the next triangle? Well, what happens with the perimeter? What happens to go from one triangle to the next? Another triangle to the next? We add 4 every time. So it's saying if you have n triangles, how would you find the perimeter of n plus 1, which would be the next one after it? You'd add 4. So part B would be add 4. C, how does your answer in part B relate to the equation you wrote in part A? Well, you would say the 4x part of the equation means that for each triangle, the perimeter is increased by 4. If you know the perimeter of n triangles, then the perimeter when one more triangle is added would increase by 4. Every single time you add another triangle, you're increasing by 4. That's how you get the 4x. Now we're going to look at page 105 in the gray region. You can describe the relationship in problem 1 by saying that the perimeter is a function of the number of rectangles. A function, underline this, star this, memorize it, staple it to your forehead. Whatever you need to know this. A function is a relationship that pairs each input value with exactly one output value. Here's what that means. For every x, there's one y. Input values are x, output values are y. So if you have x, y. Now we will use different variables, but for right now we'll be using x and y on almost everything. But your function, it's like a function machine. X goes in, y comes out. Now you have seen that one way to represent a function is with a graph. A linear function is a function whose graph is basically a line. So it says is a non-vertical line. It cannot be a line that goes straight up and down. If you have a line that goes vertical up and down, it is not. It will never be a function. A function will not be a vertical line, and a vertical line will not be a function. So make note of that. But keep in mind the whole relationship that pairs an input value with exactly one output value. That's the one thing you need to look at. All right, so now we're going to do the problem number 2, the got it. Here's our table. The first thing I would suggest you do is write an equation. We're going to start with y equals. How do you find y? And here's what I mean by that. What do I do with all of these x values to get the numbers 8, 10, 12, and 14? Here's how you do it. Ask yourself, do the x values increase by 1? Yes. So now we look at the y values. What's happening to the y values? We're increasing by 2. So that means we're going to start off by y equals 2x. So now we have to think, what happens? Am I going to add something? Am I going to subtract something? Well, what you do is take the 0, 1, 2, and 3 and plug them in. Take all of these and plug them into the x. What is 2 times 0? It's 0. 0 plus what gives me 8? That's what we're trying to figure out. Plus what is going to give me 8? Well, 0 plus 8 would give you 8. So see if that's right. Plug in the next number. 1, if x is 1. 2 times 1 is 2, plus 8 is 10. Plug in 2. 2 times 2 is 4, plus 8 is 12. Plug in the 3. 2 times 3 is 6. 6 plus 8 gives you 14. And we just graphed this, or we just wrote this as an equation. So here's what it says. Describe the relationship using words. Well, in order to find y, you would multiply 2 times the value of x and then add 8. And then you'd graph it. Now you guys can graph that on your own. You count over 0, 1, 2, and 3 on your x-axis. The y's you can count by 2's or 1's or 4's, whatever you want, and then you're going to connect your, draw your dots. All right, B is going to be a quick problem, but we're just going to look at 4 ordered pairs. You're not going to graph them, you're going to do nothing with them, but tell me if it's a function. And here's why I wanted you to know what the definition meant. The definition says that every input only gives you one output. So here's what you need to look for. Every input only gives you one output. Well, let's see. 0 gives you how many outputs? 1. Perfect. 3 gives you how many outputs? 1. But wait a minute. I have a 1 repeated. So it's telling you that if you plug in 1, you're not going to get 1 output. You're going to get 2. Can't do this. This is not a function. Not a function. Not a function. Not a function. And here's why. You have 2 x values that repeat themselves. If you automatically see an x value that repeats itself in a group of ordered pairs, bam, it's not a function at all. So if you saw 0, 1, 2, and 3 for your x values, it's a function. If you saw 1, 1, 1, 1 for your x values, it's not a function. If you saw 0, 1, 3, 3, not a function. If you saw 1, 2, 5, 7, it's a function. Nothing repeats itself. No x value can ever repeat itself to give you more than one value of y. Turn your book to page 106. I know this video is getting long, but we're going to do real quick for 2 more examples. Practice A number 3 and 4. Now, tomorrow's video, I'm going to give you a pop quiz. Here's what the pop quiz is going to ask you. What color is this screen? That's it. So you say green or bluish green, I don't care. That's your pop quiz. I want to know that you watch this. So your pop quiz is going to be what color is the screen. All right, so number 3 and 4, we're going to go through this pretty quickly. All I want you to do is write an equation. I think you guys are okay at explaining in words and graphing once you get the equation. But let's start with number 3. What happens to your x values? 0, 1, 2, 3. They're increasing by 1, we're okay. What happens to your y values every time? From 5 to 8 to 11 to 14. They increase by 3. Because they increase by 3, we start off with 3x. So now, pick any one of your x values. I don't care. So let's plug in 0. So 3 times 0 is what? 0. Plus what? Well, what number do I want for y? If I plug in 0, it says I want 5. So now you have to figure out what number goes there. 0 plus what gives you 5? It'd be 5. So let's just plug in another number and see if that works. Plug in the 2. What is 3 times 2? It's 6. 6 plus 5 is 11. That's what our table says. 3 times 3 is 9. Plus 5 is 14. That's what our table says. Number 4. The x's increase by 1. 0, 1, 2, and 3. What happens from the y values from 43 to 32? 32 to 11, or 21. 21 to 10. Each y value decreases by 11. Because it decreases by 11, that means I have a negative 11x. So let's see what happens. What's my first x value? It's 0. So y equals negative 11 times 0. Well, that gives you 0. But I want 43. So how do you get it? You add 43. So if you plugged in 1, let's see if this works. Negative 11 times 1 is negative 11. 43 minus 11 gives you 32. All of the other ones do work as well. And that is how you talk about a function. So in review, you need to be able to write data as a table an equation in words and a graph. And remember, a function is like an input-output table, x comma y. It's like a machine. You plug something in to get something out.